All right, everybody, thanks for coming out tonight. This is the third time we've met here at Interactive Resources Garage, but this is the first time I've actually done a presentation here, so I'm still getting used to all the bells and whistles. Everybody hear me okay? Oof. Again. Yeah. All right. So just to so everybody knows, one of the things that I've been doing the last couple of months is I've been taking an online boot camp on how to do machine learning and artificial intelligence. And so as part of that, we've started actually building models in the class. And so one of the things I was kind of curious about, it's like everything that we do is in Python. And it's like, well, I kind of like to run some of the stuff in the web. And so I've been doing a little research on how you can run some of these models and stuff on the web. And so that gave me the inspiration for the talk we're doing tonight. So that. Many GPUs died for that video. All right. So I just want to go ahead and start by saying that we're always looking for speakers. This is our first meeting of the year, but I currently don't have anything in the pipeline for the rest of the year. This year's at least the beginning of this year is going to be a little bit different because of my schedule. The only day I can do this meeting up through May is going to be on Tuesdays because I'm in class the other nights of the week. But if anybody's interested or has an idea or just wants to, if there's something that you even think, even if you're not interested in doing the presentation, but you'd like to hear about like a certain subject, let me know. I'll either, do the presentation myself or I'll find somebody that's an expert in that area and we'll get them to do a presentation on that. So I'm thinking maybe right now I don't have anybody that's come to me, but if I don't have any takers within the next week or so, we'll probably have a presentation on Nest.js. And Nest.js is a framework that includes a bunch of bells and whistles and stuff if you're trying to build like REST APIs. And so it's one that I've been looking at personally because it does a lot of stuff that I need, like the Open API specification. It generates that for you automatically. So that's something that we'll probably wind up doing. All right. So quickly, a little bit about me. My name is David Fecky, and I'm one of the co-organizers for this user group. I was an application engineer, but I lost that job. So my plan right now, especially doing the boot camp, is to move into doing more AI engineering. And I've worked not just with JavaScript, but with a lot of different other programming languages. Lately, I've been doing a lot of Python, which has been fun. And I have a blog where I write about this stuff, which you just go to feck.io/blog, and I have posts and stuff over there. I have a pretty neat post I did a couple days ago. Some of you might find it interesting. And then I also have a YouTube channel called The Polyglot Engineer, which I have not posted anything to recently, but I'm hoping to have some content up here in the next couple days. And I also have a GitHub page where you can find source code for a lot of stuff that I'm working on. And I also post about the stuff, not just in the blog, but also if I find interesting articles that I think other people might find interesting, I generally will post those on X to either the JaxNode handle or the Polyglot Engine 1 handle. So does anybody know what this is?
Spirit of St. Louis.
Very good, yes. That is the Spirit of St. Louis, the airplane that Charles Lindbergh flew from New York to Paris to win the Ortiq Prize. It was a 3,610-mile trip. It took, I think, like 33 or 34 hours for him to do. lot of people don't know this, that there actually were a lot of other attempts to win this prize. And he was the first one to do it. And not only was he the first one to do it, he was the first one to do it solo. There are other people who had crossed Atlantic before, but much shorter distances. And the feeling was that if you were going to do it, you had to have a crew of 4 people and a multi-engine airplane. And he did it with the Ryan NYP, which is the actual aircraft type here. NYP being New York to Paris, because it was specifically designed for flying from New York to Paris. It had a 9-cylinder engine and it held 451 gallons of gas that burned about 13 gallons per hour. So what does this have to do with AI? It really doesn't have anything to do with AI, but it does have to do with hardware. We'll come back to this. So I always like to start these off with some of the AI news that's been going on. So obviously a couple months ago, Gemini was released, and that's been a very popular frontier large language model. Google started to incorporate it into a lot of their products. And then not too long after that, OpenAI released GPT 5.2, just kind of an incremental improvement, but they're trying to stay on the same page with Google. There's a lot of competition there. Other thing that was interesting, this was a little bit sooner, is that NVIDIA Aqua purchased Grok for $20 billion. I know people have heard the Grok that's on X.com, but I'm sorry? This is Grok with a Q. And Grok with a Q, forget the gentleman's name, but the person who started that company was the same guy who led the project for the TPU at Google. He left Google, I want to say maybe about 10 years ago, started this company, Grok. And they just started releasing like a product and service, I want to say maybe about a year and a half ago. And they just sold it to NVIDIA for $20 billion. And I think that's important for a couple of reasons, but we'll get back to that in a little bit. But essentially what they do is they make specialized chips for inference. And it works really well with large language models. And the other big news is Apple, because anybody that uses an Apple device knows that Siri sucks. Apple made an agreement with Google. They're going to actually make Gemini part of Siri. So hopefully Siri will work a little bit better than it does now. So that's some of the big AI news recently. So one of the things I want to talk a little bit about for tonight was there was a kind of a groundbreaking moment in AI about 14 years ago. And that was with the release of this model called AlexNet. And so I don't know how many people are familiar with the history of that, but essentially, one of the best universities to learn about artificial intelligence is the University of Toronto. And this guy in the center here, Geoffrey Hinton, is considered the godfather of AI. The woman to his right on the far side of the screen, that's Fei-Fei Li. And she's considered the godmother of AI. And she was working at Stanford University and came up with this data set called ImageNet. And ImageNet essentially is just a collection of over 1 million images that are labeled. And so the idea that she had was that, really, if you want to do artificial intelligence, you've got to get the vision part right. You have to be able to add AI or be able to recognize things. And so she created this data set that could be used with machine learning to try to create a model that would, work well for, understanding what's in an image. And there's a lot of different, researchers and stuff that worked on this, but to the students that were, students of Geoffrey Hinton at the University of Toronto were this guy, Ilya Sutskever and Alice Kovetsky. And people that are familiar with OpenAI, Ilya is one of the founders of OpenAI. And while he was at the University of Toronto, he was working with Geoffrey Hinton on trying to build better AI. And one of the things they started working on was essentially instead of using just like a neural network, but actually using like multiple neural networks together and kind of chaining them together. And obviously, or not obviously, if you're doing or working with neural networks, they work really well with GPUs. And so they're like, well, who do we know that's really good at writing code that'll run on a GPU? And this guy, Alex Krzyzewski, was apparently really good at writing stuff for the GPU. So they came out with what was kind of a groundbreaking model at the time, AlexNet. And the thing that was really interesting about that was that not only was the model itself kind of groundbreaking, but Jensen Huang, I don't know if people know who this gentleman is. So he's one of the founders of NVIDIA and the CEO of NVIDIA. And he heard that they had used NVIDIA GPUs to train the model. This is actually Alex's computer. And what he did is he took this a desktop PC and he used two NVIDIA GeForce GTX 580 GPUs to train AlexNet on the ImageNet data. And it took I think around 5 or 6 days to train all the data. But after they did that, you know, uh, that was a lot of data they were able to process very quickly. And so people realized that, if you want to do this stuff quickly, it helps to have, the right kind of hardware to do that. So does anybody know what this is?
AC.
Close. That is an H200. And the H200 is like the latest, highest end, essentially graphics card, or I shouldn't say graphics card, but GPU card that you can use on a server. That one in particular has 8 GPUs on it, and it costs $315,000. So when you see like in the news and you hear it's like when NVIDIA has like a $5 billion valuation and stuff, that's why, because they can sell one of those for $315,000, right? So all the hyperscalers, AWS, Azure, GCP, they all make these available for rent. Generally, you can rent them like per token. And then NVIDIA also has this CUDA library that you can use for programming against that hardware. AMD also has a similar library called ROCm that you can use. And a lot of the higher end frameworks for developing machine learning and artificial intelligence models like PyTorch, JAX, TensorFlow, all can leverage this kind of hardware. So something I've been hearing a lot about the last couple of months is something called the AI bubble. And one of the reasons why I wanted to include this slide is because I think a lot of people are making comparisons between the dot-com bubble and the AI bubble, because back in around the year 2000, the internet was starting to become like a big thing with business, and all the telcos went out and they bought all this fiber optic cable. But for a long time, a lot of that fiber never got turned on. It was called dark fiber, because it's like they went out and they started building out all this infrastructure, but a lot of it just did get turned on for like maybe a decade later. And the thing that's different about this time around with AI is that there are no dark GPUs. Every one of these things that's being purchased and put into a data center is being turned on and being used. So whether or not we're making money at it is a different subject, but it's like this stuff is all being used and it's really expensive. So for that reason, I want to talk a little bit about the difference between inference versus training. And generally for training, they usually use the highest end hardware for the most part for doing the training. Inference in generally doesn't require the same scale of hardware than doing the training. But a lot of these companies like OpenAI, I think famously spent like billions of dollars on doing training. And even if you want to train like a small model, on some of this hardware, it can cost like hundreds of thousands of dollars of electricity just to train the model. And there's all kinds of different hardware now, like somebody mentioned ASICs before, but there's also NPUs, LPUs, TPUs, and of course our good old GPUs. So one of the things that I think we're going to start seeing is that there's going to be a lot more examples of where we're going to take these models and run them on lower end hardware. It's not always going to require having like a high end, $350,000, GPU in order to run this stuff. So remember this slide I mentioned before? So this is Renee Folks, S35. He crashed and burned prior to Lindbergh going on his flight. That's a Fokker C2, the America. That one actually it crashed, but nobody died. But they actually didn't make it to France until like 2 weeks after Lindbergh did. That's the K-47 Pathfinder below it. It also crashed. There was, I think, 6 different attempts for the Ortiz crash. Unfortunately, a lot of people, lost their lives. But one of the things you'll notice about all of these aircraft here that were not successful in beating Lindbergh is that they all have 3 engines. They all have multiple crew members, generally 2 to 4, crew members. The thinking at the time was that if you wanted to fly in an airplane across the Atlantic, you had to have a navigator on board that had a sextant. And a sextant's a device for looking at the stars to kind of figure out where your exact position was. It's like the old school GPS. And Lindbergh realized like you don't actually need any of that. And so what he wound up doing was he used a type of navigation called dead reckoning, where you just kind of plan your route out on a map, and then you just make slight heading changes like every 10 degrees of latitude. He even fell asleep a couple times on the trip over. Wound up kind of going into like a deep spiral, had to go around some storms and stuff. By the time he hit the Irish coast, he was only 3 miles off course. This is a dead reckoning. So a lot of times you don't need the super expensive, hardware. A lot of times you can do this stuff on less expensive, simpler hardware. So I think a lot of people are probably seeing the M series Apple Silicon chips and stuff like that. And one of the things that's interesting about this chip is this is a similar process. This laptop's not running an M5, but it has a chip that's similar to that. And one of the things that's interesting, if you look at the top right corner of this chip, there's like 10 cores in there that are all GPU cores. And then below that, at the very bottom left-hand side, I think there's like 16 NPU cores that are built into this chip. And so what Apple did was they specifically designed the hardware knowing that, there's going to be applications where they're going to be doing a lot of graphics processing and doing a lot of, artificial intelligence on the chips. This is Intel's kind of current architecture. And you can see in this example here, there's 2 neural compute engines that are part of that. I'm not exactly sure what the name of the chip is specifically, but Intel is also incorporating this into their CPU designs. So as far as consumer hardware goes, AMD and Intel both have great GPU and NPU enabled hardware. Samsung and Qualcomm also make processors, ARM-based processors that have NPU cores as well. Apple's A series, M series chips also have multiple NPU, GPU cores, and most modern hardware can run these smaller models on them. So, for instance, like the types of models that let's say OpenAI runs, as an example, these are huge multi-billion parameter models like. Even the open source ones they've done may have 80 billion parameters or whatever, and you're not gonna be able to run that on a little laptop like this. But the smaller ones, you can run on a laptop. And there's a project called Llama, which is very popular, where you can actually run a large language model on your laptop. It's a smaller one, but you definitely can. So I think the trend that we're going to start seeing, just because the cost associated with doing a lot of this artificial intelligence inference, is that we're going to start seeing a lot of it move off of the server and move onto the desktop, and even in some cases onto the device, like something like this. So why do we need GPUs and NPUs? What exactly do GPUs do? So GPU stands for graphic processing unit. The math needed to calculate graphics is built into these chips. So they've specifically designed the chips to be able to handle the type of compute you need in order to, do, 3D first-person shooter type games. But that kind of math is generally, there's a lot of linear algebra, matrix multiplication, dot product. That's generally used in building those 3D games. Well, it turns out that same kind of math is the same kind of math they use for doing these neural networks. So NVIDIA back in 2007, I think, actually came out with the CUDA framework specifically for people that were doing scientific research. But it wasn't really until AlexNode came out in 2012 that people really saw the power and importance of what you can do with these large language models. Oh, sorry, not large language models, but these large AI models. So how do we run this stuff on a web or a device, right? So there's a number of different, features in modern web browsers and Node.js that allows us to, run these types of models, locally or on our own servers. One of those is called WASM or WebAssembly, and that's been around for a little while. Probably about 7 years is when it was first introduced. There's also a newer technology, it's a couple of years old, called WebGPU. And there's a newer one that's really, I think is really kind of like in the alpha or beta testing stage called WebNN, which is Web Neural Network. So the nice thing about WASM is that you can take code that was written maybe in Go or C++ or Rust, and you can actually compile it down into intermediate language that will run inside of the JavaScript engine. They have a specific part of, like V8, for example, can run WASM as an example. And then with the web GPU, which is now available in most browsers, you can also run a lot of this code with the GPU. So you can write code that targets the GPU and then use the GPU in your WebAssembly type applications. And there's a framework called Onyx, which is a format specifically for being able to run on the web in Node.js, but actually you can run it in a lot of different places this way besides just the web. There's another framework called Transformers.js. It's from Hugging Face. Is everybody here familiar with Hugging Face? Okay. So one of the things that's nice about Hugging Face is that they have this section called Spaces, where you can actually go and kind of like demonstrate, like a little application showing off, what you can do. And some of those cases, they're kind of like server-based applications, but there's a lot that are actually just purely web-based applications. And I have a couple demos tonight I'm going to show that are like completely web-based. And it's specifically built to be kind of like a higher level way of working with like, image recognition, large language models. The only downside to this, well, more than one downside, but is that these models are limited to about 4 gigabytes. That's about the largest model you can run on a web browser, at least right now. So the Open Neural Network Exchange, this is the model format that you can use to run on the web and mobile. Like I said, it's not only for JavaScript, but they have ways that you can run it. They have libraries that you can use with C# or C++, Python, Objective-C, Rust. Basically pick a language, and there's a way of running them. They work well with most of the Gen AI models as well. And it's very easy to take like a model that you're working with and convert it to that format. So the model format in particular, you can actually take like your PyTorch or TensorFlow models, even scikit-learn, and convert them to the ONNX format. These models can also be downloaded directly from like Hugging Face's example. So if you're using like Transformers.js as an example, they actually have a mechanism where you can just name the model, and if it's on Hugging Face, they'll download the model so you can use it in your web browser. And then, one of the things they encourage is that, just because like, I don't know about you, but like if I'm going to run something and I have to sit there and wait for, 40 gigabytes to download, that's kind of a pain. And especially if I'm doing it over like some crappy cellular network, so I don't want to sit there and wait forever for the model to load. So one of the things they encourage is they use this term a lot called quantization. And quantization essentially is taking like a larger model and making it smaller. And the way they do that is they convert a lot of the weights from either being 64 or 32-bit weights down to 16, 8, or even 4-bit weights. And when you do that, the model's not as accurate as it would be if you're using the larger data type, but you can get them so they're really fast and really performant when you do that. So there's a lot of Llama models out there that are as small as 1 gigabyte. I'm gonna take a quick water break here. All right. So I mentioned a Llama before. Llama essentially lets you run local large language models on your desktop. And you can also use Transformers.js to run these large language models directly onto into the web browser, as an example. But you can also use it for doing stuff like text to speech or speech to text type of processing. There's also you can do image and video recognition systems as well, which is pretty cool. Even something as old as OCR you can do with that as well. And of course, natural language processing and classification systems can also be done with that. So this is an example of how to use Transformers.js. So it's actually the thing that's great about this framework is it's really, really easy to use. So all you have to do is just import a pipeline from the Hugging Face transformers, and then you create a pipe. So in this example, it's using sentiment analysis, and it's specifying a specific model here. So here it's using the Zenova BERT-based multilingual encased sentiment. And then once you've created that pipeline, all you have to do is pass your parameter or parameters into that, and it'll give you an output. So very simple, very easy to use. Yes.
Is it like using something in Docker? Like, is there like a registry of models? It's like here you specify a really specific name. Is that how it works, or do you have to provide the model as well?
So actually, you can either provide the model yourself, or you can just go into Hugging Face and use one of the models that's been uploaded to Hugging Face. So Hugging Face would be like the Docker Hub in this case.
Okay.
All right. Slide. All right. So if you just want to use ONNX by itself, this is a little bit lower level than using Transformers.js. You can actually do that as well. All you have to do is create a inference session. And one of the things that's a little bit different from Transformer.js is like when you pass in your inputs and run a session on this, it's actually expecting something called a tensor. And a tensor is a special data type that does not naturally exist in JavaScript. So they have a way that you can create or instantiate one of these tensors. And I can talk about that a little bit later if somebody wants to know exactly what a tensor is. But obviously, if you've heard the name of a framework called TensorFlow, it's actually named after tensors. So it's kind of a key data type that's used in machine learning. So as far as what we have to do, the training, typically, if you're going to do your own model, train your own model, even fine tune a model, You can do that using Python. So most AI always seems to start in Python, and then they realize that Python is incredibly slow, and they wind up having to go and optimize it in another language. But there's a ton of frameworks out there for doing machine learning and building these models. So scikit-learn is very popular, mainly in the educational space, but companies like Meta and OpenAI, most of the big companies are using PyTorch. PyTorch, there was a kind of competition a while between TensorFlow and PyTorch. I think it's safe to say PyTorch, won that race, but they both do, very similar things. And then, no matter which of these frameworks you're using to build your models, you can just add Onyx into your Python app and just, if you're using scikit-learn as an example, you can use the SKL2 Onyx library, and it creates a, converter that will take your model and convert it into a model that will run in an Onyx runtime. And so all you have to do is use like a method like toOnyx. It's a function that will convert your model to an Onyx format. And then once that's done, you just take that model and you copy it over to whatever application you're planning on using. So this part, we're actually going to do a couple demos here. This is the first time I've actually presented here, so I'm going to try to take the laptop and put it in my lap. Let's see how that works. So let me do this. Might come over here. All right. All right. Why is that? Let's see. I'm having some technical difficulties here. Just bear with me 1 second. Maybe how about cancel?
Are you full screen?
I am.
What
Yeah.
happens if you do like a 3-finger swipe left or right? Am I not sure? F11.
F11. Let's see here. F.
What's the issue?
Well, my screen is kind of locked. Let me try this. There we go. All right. Whew. All right. So I'm going to open up VS Code here. I can remember where it is. There we go. All right. So actually, I have this. I have this up on GitHub, and I'll show a little bit later. But essentially, what I did was I created a monorepo, and in the monorepo, I have 3 different JavaScript applications, and then I also have a Python notebook, interactive notebook. I will. I just need to figure out which one I'm going to do first. So let me do this first. I'm going to open up. Let's do this. Let's actually run some examples here. That'll be a little bit easier to just kind of see what we're doing. So I mentioned before that I'm actually going to be using, or I had some examples that were just entirely web-based. So I'm going to run Llama in the web browser and see what that looks like. So can everybody see that okay? All right. So what I'm going to do is I'm going to come over here and I'm going to load this model. And you can see that it actually just downloaded a model from Hugging Face. And then I can come here, I can ask any questions. So I can ask it, why is the sky blue? And not only is it giving me an answer that's fairly accurate, it's doing it at about 40 tokens per second, which is not bad. It's pretty quick. So, so that's one demo.
That's not using an API, that's straight up.
Oh, no, it's using an API, but specifically this is all JavaScript based, or I should say like WASM based. So if we're going to take a look and see how that actually works here, I'm going to blow this up a little bit so it's a little bit easier to read.
It was running the llama inside the web browser.
It was running the llama inside the web browser. And the way that that works is that this is actually just a React application. And what it's doing is it's actually loading all this stuff up using the transformers library from Hugging Face inside of a web worker. So it's using a web worker to actually go through and do all of the, the work of essentially streaming the response back out and then displaying it into the React application. And so the React application itself is just, just a plain, simple React application. So there's nothing running on a server. This is all running locally inside the web browser. And then another example I have, which I think is probably might be a little bit more useful, is one of the things I've been thinking about is like, well, how could I actually, use this like in my day job as an example? And so, one of the things that I know that people are looking for is like help, translating things into like a different language. And one of the things that's in particular handy about AI, especially AI, it's based off of the transformers technology, is that it was originally kind of developed as a way of being able to translate from, one language to another language. So I can come over here and I can say, I want to figure out, well, how do I say I love walking my dog in French? So I can come over here and hit translate. And you can see here that it's coming as loading models. So there's a little bit of a hit, to download the models the first time, but once they're loaded and they're actually in the browser, then it'll actually will go through here and start executing that change. There we go. And if I want to do that in a different language, I can come over here and select like Spanish as an example. Pero. There you go. Or if you want to use Esperanto, any Esperanto speakers here? They'll come over here and translate it into Esperanto. All right. So as far as like actually building a model ourselves, one of the things I wanted to demonstrate tonight was like how we could actually build a model ourselves and then take that and then use that inside of a web application. So what I've done is I've created a notebook here, just called train model here. And unfortunately, let me kill these. I don't do this right.
Yeah, well, these are your GitHub.
Yeah, this is all my GitHub. So I have a QR code that I'll display a little bit later. And actually make clear. Didn't want to have this stuff here. But anyways, so one of the things I love about Python is interactive notebooks. And so I can come over here and I can say, here's all my imports. And I'll come here and I'll run imports. You can see I'm loading up, some very common, very popular Python libraries like pandas, for working with tables of data, NumPy for working with numbers, matplotlib for graphing things. And then I also have some libraries here specifically for doing training. And so for tonight's example, I'm going to use the hello world of AI, which is called linear regression. And I'll show you how that works. So here I've got some housing data here I want to have loaded up. So I'll hit that, it loads it up. And then if we take a look at this, I'm using a head method here. This is actually using pandas. And so I've loaded this data set up, but it's a very simple data set. It just has a couple of features and one target. So the features here are square footage and bedrooms, and then the target is price. And so I'm just going to, for the basis of my model, I'm just going to use square footage, and then price will be the target. And then I can get kind of a quick look to see what this looks like. And so here I can see that I've got, a very small sample set, 55. This probably wouldn't be very good for practical reasons, but it's a small data set. And then if for generating the features, I just come here and I select the square footage for my features, and I'm going to select the price for the target. And when I go to run that, it just essentially takes those columns and puts them into their, into the X and the Y variables here. And then if I want to see what that looks like, I can come over here, I can generate this this graph. And one of the things, I don't know how well we can see the whole graph here, but you can see here that this is a scatter plot. And the scatter plot, it's kind of showing here, it's giving us the square footage over the price. And we can see as the square footage goes up, so does the price. And one of the things we can tell from looking at this is actually a fairly linear line. You can almost draw like a straight line from the beginning of the data to the end of the data. And that's kind of a good model for using a linear regression when you see data that looks like that. So to actually train the model, we're actually going to use this train test split method. And what that does is it takes our data that we have that we loaded up originally. And what it does is it does, like in this case, I'm doing a 0.2, which is going to make it an 80-20 split. So I'm going to use 80% of it for the training data, and then I'm going to use 20% to actually test the model once I'm done. And then if I go here and run this, it actually creates a linear regression model. And now what we want to do is we want to take a look at the model itself and see how, if we lay it down over that data, what does that actually look like? And so here I have another scatter plot where I'm also drawing a line on that. And so we take a look at this, we'll see here that now we've got a line here that kind of fits that data, right? So this is what's referred to a lot of times as a line of best fit. And now that we have that model, I want to actually do an evaluation to see how accurate it is. And I'm doing a test here where I'm trying to get it to predict if it's 2,400 square foot, home, what price do you think it should go for? And in this case, it gives me $375,000. And then I'm doing what's called the R2 score on that. And the R2 score essentially is telling me, it's taking the test data and seeing like how accurate my results were. And so in this case, it's about 92% accurate. So not too bad. Now, what I want to do is I want to take that model, I want to convert it so to something that I can actually use. So I'm actually using Onyx here to convert this to Onyx. And so what this is doing here is I've created a new model called housepricer.onyx. And then I'm just writing it out. And if I want to, I can just evaluate it right now inside of Python by using this code cell. And if we look at that, we can see that it comes back with this prediction of $375,677.97 based off the square footage. So now that we've done that, I'm going to copy this to a Node application. So I'm going to go here, I'm going to run that. And now it's copied that file to this project right here. It's called local node AI, or sorry, JaxNode AI local. So in this, I have two examples. The first example here is just using transformers to do a sentiment analysis. But the second one, I'm actually using this model that we just created to actually run a check. And so to do that, what I'm doing is I'm creating a session, and then I'm running that session. And in that session, I'm passing in a tensor. And the tensor, I'm just passing in one value for that 2,400 square foot. So if I come over here and I go to run this, we should get a number back. This is exactly the same what we saw in the Python code. So now I could, if I wanted to, I could take this model, I could use this in a React application or Angular application. It really doesn't matter. It'll run in any one of those applications. All right. So we pull this up. So I took all the source code, the slides, I have them all up in a repo in the JaxNode user group. And I also have it listed here. So if you just go to github.com/JaxNode-UG, run AI models on web, it's all there. I'll leave that slide up there if anybody wants to get a picture of that.
Or did you go back to the largest?
Yes, for the web, yeah. So something else you can also do, this is one of the things before I tried to do it with the web, I was curious, like I had a model where I was taking multiple different parameters in, for predicting used truck prices. And I was like, I remember, Apple has this library called CoreML. As bad as they've been with Siri, they actually have a lot of other AI stuff that's really cool. And so
What was it called?
Core ML is the name of the library. And so one of the things Apple did was pretty smart was they actually created a Python library. So all these people that are building models in TensorFlow or PyTorch or even scikit-learn, you can take those models and convert them not just to an Onyx model, but you can also convert them into a Core ML model. So one of the things you can do with Onyx is you can actually take an Onyx model, you can run it on an Android device, but you can also run it on an iOS device. So you can run Onyx models. There's libraries that you can use for running Onyx models on an iOS device. But the this Core ML tools framework you can use in Python. One of the things you can do with it is you can actually go and take in this case, a scikit-learn model and convert it into a Core ML model, and then just use that inside of your Mac app, your Apple TV app, your iPad app. It'll just work. So I think I have an example here I can show of that. So this right here is actually a model that I created using Core ML. And one of the things that's nice about once you've taken this model and converted it into a Core ML model, it actually gives you this really cool tool for visualizing the whole thing inside of Xcode. And then if I go and run this, let's see here. So I've got this little app here where I can come over here and I can just start moving this sliders around. And it comes back and it actually show me here's the age of the truck. And then I can add mileage to it. You can see the dollar price starting to go down. You can also, there's other features like whether or not it has a V8 engine, four-wheel drive, it's a long bed, short bed, and it updates the price right there, all in real time. So, and that's all just using a model that I built using scikit-learn, and then I just converted it into an app that you can run. So the nice thing about this is like once you figure out how you can actually build or start working with models, you'll start to learn that you can actually take these and convert them into something that you can run on the web or run on a Node server or another server for that matter. So I think this is just, I think we're really just kind of at the beginning of a lot of stuff that we're going to start seeing. I think one of the big things that we're starting to see right now with as far as AI development is specifically AI engineering. And specifically, people are trying to figure out how they can write applications that work with these models, but also you can supplement the model or improve the model by essentially writing software like MCPs as an example. So I think that's kind of like where a lot of the work right now for working with AI is there's going to be a lot of work just around the edges of doing kind of building the software that's needed to support the models. And that is about the end of everything that I had to present on. Let's see if I can find my slides. Were there any questions? Mike?
So this implementation puts everything on the client side, if I understand?
Yes.
So all you're doing is generating the model and distributing it?
Correct. Yes, I'm sorry, Andy.
Yeah, but no, I was just curious, like, that model, when you generated the model in Python, and then you pushed it up to what exactly was that model that you were pushing? Is it stored somewhere? I mean, outside of it?
It's stored in a file. It's stored in a file. So what I did was, when you train the model, essentially it's trying to do everything it can in memory, right? And then what we're doing is we're taking that model that's in memory, and then we're saving it out. So with scikit-learn as an example, there is a kind of like a default format you use. It's called pickle. And so you can actually take a model that you've trained and then save it as a pickle file. But that's just so you can load it up again and use it again in your kind of your existing, Python scikit code. But if you want to use it in a different language, what I used this Onyx toolkit specifically for saving that model out from memory into a specific file format. And so the Onyx is a specific file format that you can use. And it's the most universal AI model framework that you can use. Yes, sir.
The web application, created, is that anywhere exposing data to large language models outside?
No, it's all running internally. So the question was when we're going to run these, like for instance, when I went to go run that Llama model in the web, is it going out and hitting a server to get that data? It's all running on the front end. There's nothing going back talking to a server. Something that's interesting you can do. I don't know if anybody here has downloaded or played with Olama on their local systems. One of the things you can use is you can use a tool like Wireshark or whatever and look to see if there's any communication stuff going back. Yeah, that's one of the concerns I think a lot of people have had with some of these tools. It's like if I'm using famously Apple did not allow their developers to use OpenAI because they were afraid that that it would take the code they were in their context and pass it off to OpenAI. But now actually in Xcode you can actually use OpenAI inside of Xcode. So they actually have a chat bot built into Xcode. Most of the vendors now, whether it's Cursor or it's VS Code or Visual Studio, they have like a chat bot now that you can run almost all the IDEs for doing this types of stuff. But yeah, it's an interesting thing. So you can see for yourself, run a utility like Wireshark on your computer to see if it's talking back. It's not. And there's another company called Perplexity, which I like a lot. And one of the things they've done is pretty cool. I mean, they have their own chatbot / search engine. But one of the things they do is they actually go out and they take a lot of the open models or open source models. And if it's from, let's say, China, for example, DeepSeek, for example, they took the DeepSeek model because it was an open source model, and they went back and they fine tuned it to kind of fix a lot of the things, essentially decommunist the model. Because there's things like if you search for what happened in April 15th, 1989, it just wouldn't answer you like if you used it on the Chinese website. But if you use Perplexity's version of the model, it will tell you the correct answer. Yes.
You mentioned like the 4 GB limitation on model size a couple times.
Yes.
Where does that limitation really come from, right? Is it max that you can serialize into a file? Is that an Onyx restriction? Is that WebAssembly performance just degrades? Like, where is that limitation coming from?
My understanding is that it's actually coming from Chrome. Okay. So there's a limit on how much you can load into Chrome. But this is what I would say about that is that if you have, I used to work at a company here in town that was down off of Riverside. And I remember I had an iPhone and I would go and try to access like a web service that I had written from my iPhone. And I remember the first time trying to use it, it was a SOAP-based, I'm embarrassed to say this, it was a SOAP-based web service. And it took like a minute once I made the request to get the response back. And most of that just had to do with the time the data access, the cellular data was so bad in downtown Jacksonville that it's like, it just took, it was to get 15K of a web response. It just took forever to load up. And so even with 5G, a lot of these faster networks and stuff, so you probably don't want to have your user downloading 4 GB in their mobile browser. Something that would be better, especially if you're using like a mobile app, is to have an actual app. Go to this guy, because I know he does mobile apps. And I think React Native actually has a library, as an example, where you can take a model and even with the app stores, I haven't looked to see what Google's is right now with the Play Store, but I think there used to be like a two, like I think, I don't know what the limitation is now, but it's like there used to be like a 2 GB limitation, I think, on the on Apple's App Store. So you can put a lot of stuff in there. I've always like was shocked. Like I looked to see some of these app sizes, like the Facebook app. Like the last time I looked, which was probably close to a decade ago, it was like 500 megabytes in size. Are you kidding me? That takes a long time to download an app that size if you're especially if you're on a cellular network. So yeah, I would say like there's probably going to be like this transition period where we're still doing a lot of stuff like on the server, like using these hyperscalers to do a lot of this stuff. But just the economics of doing that, it's like it makes sense if you can run it on the user's device rather than running it in AWS or GCP that you're paying for by the token. It makes a lot more sense if you can run this stuff on the device. Just because it winds up as a business, it winds up costing you a lot less money.
So is it loading all the file if it's 4 gigabytes, is it using 4 gigabytes of memory as well? Can we see like on Chrome when you run the Lambda?
We can take a look. Oops.
I had a question similar to that too.
Yeah.
As you scale, as you train more, will that file gets bigger and bigger, or how does that work?
Yeah, so the thing is the models themselves have become really, really large. And there was a thinking for a while that the big catchphrase for the last couple of years has been AGI. We've got to get to AGI where where the models essentially can think for themselves. And a lot of people like Mark Zuckerberg, as an example, bought into this idea that if you just train the model on more and more data, make the models bigger and bigger, that the models will get smarter to the point where they can think for themselves. And the head researcher that he had working for him for a long time, Jan Kuhn, I think was this guy's name. He just recently left Meta, and for a number of reasons, but I think one of the reasons why was because I think the people that really know what they're doing don't believe that you can reach AGI by using large language models. We're kind of at the point where we're kind of spinning our wheels with that. So one of the changes that they're doing now is people here have heard of a term called mixture of experts. So mixture of experts essentially, like the way it works with like DeepSeek and OpenAI, as an example, is instead of doing one gigantic, model, what they do is they actually train models on very specific targeted things. And then what they do is essentially they have like a router that runs in the main model itself. And then what it does is it picks which is the best model for answering this question. And then it provides an answer. They're doing a lot of other stuff besides that, but that's one of the changes they made. So instead of being like doing one giant model, what they're doing now is they're actually starting to make a bunch of different models and kind of combine them together. And even the stuff that I've been learning, there's terms called boosting and bagging, that sort of thing, where you can actually take multiple different models together and kind of combine them together to get a single answer. So in that case, the individual like files themselves, if you're training or you're building a model that way, the model will just keep on getting bigger. But I think the way that they're going to be engineering this stuff to run off of off of the server example is they just have it kind of route to the proper place. Yeah, Eddie.
With the browser, one of the things that we run into with the big ones, is the hallucinations. Is that an issue with these, smaller ones that's on the browser?
So the example I showed earlier, the llama running the 1 GB model, I had some fun playing around with that. And one of the things I did was I asked it, it's like, well, what are the visual flight rules if you're going to be flying in an airplane that you want to fly without having to file an IFR flight plan? It's like, what are the distances from the clouds, like below the clouds, above the clouds, horizontally from the clouds, at below 10,000 feet, above 10,000 feet, below 18,000 feet. There's all these different rules that pilots have to follow as far as like how far you have to be away from the clouds. And I asked Olama that, and it just said, "Oh, 5,000 feet above, 5,000, below." And it's like, no, that's completely wrong. So that's part of one of the problems with quantization is that you make the model small enough to where it can run in the web browser, but it's not very smart. And one of the best things you can do is to try to compensate that. So one of the things that people are doing is to try to handle like very specific tasks, like agents, as an example, is what they'll do is they will write something like an MCP, for example, which can essentially give additional context to that model. So you can make the model a lot smarter if it's trying to ask like a specific question based off of, say, maybe your application, your data. You can have an MCP that goes out, looks that up, you register a tool with the model, and then what I'll do is I'll say, oh, well, I don't know the answer, but I think I'm going to look it up. Another tool is something that's called RAG, which is when you are doing your initial prompt, what it'll do is it will actually use a vector search engine to get additional context that matches the prompt. And then it'll take that context and dump it into the request of the large language model, and then it can do a much better job. So
What's it called?
RAG, it stands for Retrieval Augmented Generation.
Oh.
Yeah. And so I think one of the funnier memes I saw a couple of years ago was that I'm going to go and start my own AI company. And what is it going to be? It's like, well, I'm going to have a website where somebody can go and upload a PDF, and then it'll answer questions based off of my PDF, because that's kind of like the hello world example of a RAG application. But yeah, so there's all kinds of different ways that you can augment large language models by giving them additional context. Sometimes it's just as simple as providing as much context up front. So but there's little tricks and stuff they've added into them. So the big thing that's been kind of like revolutionary over the last year or so, if you've heard the term MCP, which stands for Model Context Protocol. Essentially what those are, there's just a small little applications that follow a specific protocol. So they can either be like a web-based, like a web API, or they can be something that runs on the I/O of the computer. So you can run them on the same computer as the large language model. And then what you're doing is you're registering a tool with that large language model. So when you start the application up using the large language model, you say, hey, here are the tools that you have. And so one of the things that large language models are famous for being really bad at is like math, which is ironic because they all run off of math. But they're really bad at answering questions around math. And so the way that they've augmented these is they've built these little applications that are, augment the large language model that actually go out and do like a tool call. So you register a tool. So a good example of this, I have an example that's on the website for MCP that uses my aviation weather service. And so I can go to a large language model and I can say, hey, I want to know what the weather is like right now at Jacksonville International Airport. And it's smart enough to know, okay, well, the identifier for that airport is JAX. And then it'll go out, make a call to that tool, get the information back, and even format it, Markdown to make it look pretty and stuff. in the response. So the LMs, already do a lot for you, but they don't typically have access to real-time information. You can actually create tools that supply those to the large language models. Yes.
When somebody asked the hallucination question, and it kind of sparked a thought, how many R's in the word strawberry, and it keeps.
Yeah.
The question where you asked, why is the sky blue? Have you thrown that question at it? I'm curious if it actually comes up with the right answer.
Well, I've thrown other questions at it where it just gave me an answer that was kind of like in the area that was like completely wrong. I don't want to say hallucination per se. The most of the frontier models are doing a much better job with hallucination, but there used to be like, if you went on to JetGPT when it first launched, you could ask it, what were the top 5, movies in 1985? And it would give you like maybe 3 or 4 of them that were correct, and it would just completely make one up from scratch. And so hallucination, it was a really bad problem. But one of the things they've done is, if you're using ChatGPT now, as an example, a lot of times when you are making a prompt, you're querying their engine, what it's actually doing is it's actually going out and making a web search. And it's looking at stuff on the web, and then it's using that as context in the answer that it gives back to you. So they've gotten a lot better at at that specific problem, just because they're using tool calls to do a better job of answering the question. But if you're using something like the 1 gigabyte Olama, it's going to hallucinate a lot. So you probably don't want to use that just by itself. You might want to augment it with some additional tools.
I like the attitudes when it's like, I don't wanna do that, or, I don't know if you guys run into that at all, but we do summaries a lot,
Yeah,
and it'll say, I am uncomfortable doing this, it's like, it's just a summary.
yeah. John, you had a question?
Yeah, did you do the sky question on the Obama? I thought you did that for the demo.
I did, yeah. I asked like,
Yeah.
why is the sky blue?
Was the answer pretty good? I forget.
Yeah, he gave you the Rayleigh tracing answer, which is the typical answer you get back from any of those models. But like, I've done like other questions, and it's just like completely wrong. So
With the truck app that you built, how many data points did you train on, and where did you get your data from to train your truck model?
I'm currently taking I'm in a AI/ML bootcamp, and they actually gave me the data in the bootcamp. But there's a lot of stuff that a lot of stuff that we're using, you can just find on Kaggle. So Kaggle is another popular. It's similar to Hugging Face, where you can look up models and data sets. But the key thing there is you can look up data sets and then use those data sets to kind of practice training a model. So Hugging Face and Kaggle both offer that. And so the stuff that I've been doing myself, just to kind of experiment, I've just been downloading it from Kaggle. So like one of the first data sets that we used in my class was the Titanic data set. That's a very popular one. Just because it's got its little problems in it, like it's got some missing data and stuff like that. You have to learn the different tools that data scientists would use to kind of be able to work with that data when there's missing values or there's things that wouldn't process correctly.
Just Kaggle hosts models, you said?
I believe so, yeah.
Yeah, because I remember them just as like a contest website.
Oh yeah, that's the other thing that's cool about Kaggle is that they do these contests.
What's it called? Kaggle?
Kaggle, it's spelled Kaggle, Kaggle.com. And let's see if I can pull it up here.
I went to a meetup in Boston where the whole meetup was just them doing Kaggle problems. And just like trying to compete.
Yeah, there's been some like big prizes and stuff like that, but it's funny to see like the techniques they're using to solve or to come up with like the best answer. Because like when I was talking about AlexNet earlier, I believe when they first did the paper on that, it's gotten a lot better. But I believe the original like accuracy of that model was like like 76% or something like that. I mean, it was not like 100% accurate, but they've been able to like make all these improvements. And the way they're doing it is that they're not using one model. They're actually using multiple models. I learned this week. They're actually taking, they can either take different models, run them sequentially, or they can do them, run them in parallel. And, to train the model and to, get back an answer. But that's very similar. Like, if you actually read the AlexNet paper and look at how they actually implemented that, it's just a series of neural networks that run in sequence with each other. So it's, but that was like the first like big model that was done, where they used like deep learning. That's my understanding. It was the first model that used deep learning.
Are you doing your boot camp?
I'm just doing it online, through a school called Full Stack Academy. So it's like 3 days a week for 3 hours each day, and then it's for like 6 or 7 months. So it's pretty. Like most like boot camps, like I've heard about, like the ones that you just do straight, it's like 12 hours a day for 5 days a week for like 12 weeks or something like that. This is over like 7 months. So the nice thing about it is that you can actually, work and earn a living, and then do the class. And it's been interesting because like most of the people that are taking the class, like 85% of them, have never had like any programming or done any programming before. So I was basically able to kind of like, like sleep through like the first month or two. Now I'm actually starting to have to put some work in. So, but yeah, it's pretty interesting to see how other people like learn this stuff. One of the guys that's in my cohort, like he's been programming for forever, and he initially started programming using cards, like your card readers, where you type out like a line of code on a keyboard, and it would just make a card with all these punch holes in it. Then you run that through a card reader and stuff, and so this is a lot easier doing that. It's like, yeah, it is. All right. Well, I'm gonna go ahead and stop the presentation. I want to thank everybody for coming out tonight. And let's see here, do this. Did I actually stop this? Here we go.
You get the top.